Okay, so tomorrow's quiz, we have a quiz tomorrow. It's going to cover 7.1 to 7.3. There are 10 questions. On this quiz, no proof, no, sometimes, always, or never questions. It'll be on the test probably as well as the proof. The majority of the questions are calculations. You will have to, just like you just did in the warm-up, you will also have to identify what theorem or converse you would use to prove that a quadrilateral is a parallelogram. So know your proofs, not necessarily how to write a proof, but know the theorems that you would have used in your proofs. Know how to apply those theorems and those converses. So let's go ahead and take a look. So the quiz looks very similar to these warm-ups that we're going to go through. Now, there are additional types of questions that are on the quiz, so don't always just focus on a warm-up or a review. Go back through everything. Go back through your homework, your notes, your review that is posted. There is a review that is posted. You do not have to submit it. It is there for you to use to study tonight. You don't have any official homework that needs to be turned in tonight. Your only homework is to study. Also, no calculator for tomorrow. You're going to do all these calculations by hand. Let's go through the warm-up answers. Now, before I do this, let me tell you the 4 formulas that you need to memorize for tomorrow. So, first of all, whenever the question asks you to find the sum of the interior angles, we're going to be using the formula n minus 2 times 180. That's the formula that you needed to use for number 1 on this first 7-1 warm-up. If it said to find the measure of one angle or one interior angle, it may say, like on the warm-up, it said an angle, or it could say each angle. So when it wants you to find one angle that's in the interior, we're using the same formula, but we're going to add one more step to it. We're going to divide that sum by n. So these are 2 of the formulas you need to memorize. The other 2 are when it asks you to find the sum of the exterior angles of a regular polygon, that is always going to equal 360. So no calculation there. But if it asks you to find each angle or each exterior angle, then you're going to take 360 and divide it by n. You also need to know the polygon names. And what I mean by that, let's say instead, question number 1, since I told you it was a 24gon, you knew your n value was 24. But what if I changed number 1 and instead I said find the sum of the interior angles of an octagon? Then you need to know that an octagon has 8 sides and your n value would be 8. So you need to know the polygon names, because when I ask you to find the measures, I'm going to give you a name, not a number. So be ready for that. So those are the things you're going to need to memorize, as well as the theorems and the converses, and be able to apply everything. Let's do the first one. So it says to find the sum. So we use the n minus 2 times 180. My n value here is 24. 24 minus 2 is 22. 22 times 180, and that sum will be 3,960 degrees. For the next one, it's giving us the sum of the interior, and it wants us to find the n value, the number of sides. I'm still using exactly the same formula, but now I'm going to set that equal to the 5,040. I'm going to go ahead and just distribute the 180 to the n, to the 2. And now I have a nice two-step equation that I can solve by adding 360 to both sides. Once I add the 360, I get 180n is equal to 5,400. I'm going to divide both sides by 180, and my n value is going to be 30. So this would be a 30 gone. So be able to work backwards of any of those formulas that I wrote at the top of the page and to find the number of sides. Now, this time they're giving me all the exterior angles in the picture. And remember, the sum of the exterior angles is always 360. So to find the value of x, I'm just going to add up all those exterior angles and set it equal to 360. So x plus 3x plus 72 plus 46 plus 110, and set this all equal to 360. I'm going to go ahead and combine my like terms. I have a 1x and a 3x to combine, and then I can add 72, 46, and 110, and that gives me 228. I'm setting that equal to 360. I need to subtract 228 from both sides. I get 4x equals 132. Divide both sides by 4, and x equals 33 degrees. So the value of x is 33. For the next one, it wants me to find the measure of both the interior and an exterior angle of a regular 36gon. So let's do the exterior angle first. So all I have to do is take and use the formula 360 divided by n, and my n value is 36. So 360 divided by 36. I put 360 in the box, goes in here once, bring down the 0. So it would be 10 degrees for the exterior angle. However, for the interior angle, I'm using the formula n minus 2 times 180 divide by n. I get 36 minus 2 times 180 divide by 36. 36 minus 2 is 34. Now, you can either multiply and then divide. I'm going to simplify before I multiply. I used to always show this to my Algebra 1 class because we never used calculators. So I could simplify and divide 34 and 36 by 2 and make this 17 and 18. Now, you don't have to do this. You can just do 34 times 180, get that answer, and then divide it by 36. That way works as well. But this is a lot easier because then I could also simplify the 18 and the 180, make that a 10, make that a 1, and now I'm just left with 17 times 10 over 1, which is 170 degrees. So the interior angle is 170. Okay, so one, we know that opposite angles and opposite sides are congruent in a parallelogram. So to find the value of A, I am going to set A minus 12 equal to 30. I'm going to add 12 to both sides, and A equals 42. I also know that opposite angles in a parallelogram are congruent. So to find the value of B, it's just B plus 10 equals 36. Subtract 10, and B equals 26. To find the measure of angle K in the parallelogram, I also learned that consecutive angles in a parallelogram are going to be supplementary. So in order to find K, all I have to do is subtract L from 180, and I get 116 degrees for angle K, because these two are supplements. Now to find BCD. BCD is located over here, so it's this whole angle right here. Now remember, since they're telling us that this is a parallelogram, I know by definition a parallelogram has opposite sides that are parallel. So if I draw that BC is parallel to AD, and then if I use BD as a transversal, I've just created a pair of alternate interior angles that are congruent. So this angle up here would be congruent to the 37. I could also use the other diagonal as a transversal, and then the other sides as parallel sides. So AB is parallel to CD, which then makes alternate interior angles here with 100 and 100. Now, the reason why I found those alternate interior angles is I need to find the measure of this whole angle here by adding 100 plus 37, and that angle ADC or even ABC up here, these are going to be 137 degrees. And I know it's going to be a supplement with the angle I'm looking for. So all I have to do is 180 minus 137, and my missing BCD is 43 degrees. For the next part, they're giving me the length of BE, and BE is right here. It's this piece of the diagonal. And I know in a parallelogram, the diagonals bisect each other. So that tells me ED over here is also 9. So to find the length of the entire diagonal, all I have to do is add 9 plus 9, and BD equals 18. Now on to 7.3. We learned 5 ways to prove that a quadrilateral is a parallelogram. Remember, we can use our converse of, so we could say that opposite sides are congruent. If we can show that both pairs of opposite sides are congruent, then we can use that converse. Or if I show that both pairs of opposite angles are congruent, I can use that converse, the parallelogram opposite sides converse. I could also show the parallelogram diagonals converse if I can show that the diagonals have been bisected. And that's what's happening here. So I can either state in words that the diagonals of this quadrilateral are bisected, therefore it is a parallelogram. So you can either describe it in words, what you see, or say by the parallelograms, diagonals, converse. Just give me the name. Either way. Now for the next one, we don't know that this is a parallelogram yet, so I can't assume that this angle is 100 yet. What I need to do is do the calculations. I know it's a quadrilateral, and quadrilaterals angles all add up to be 360. So I'm going to add 80, 80, and 100, get 260, subtract that from 360, and then I can show that it is 100 degrees. So I can either use my parallelogram opposite angles converse, or I could also show that the consecutive angles are supplements. Either way. So probably the easiest one would be the parallelogram opposite angles converse. And what I just showed were that both pairs of opposite angles were congruent. The next one, I'm going to use those consecutive angles. And I know that when I have a pair of consecutive angles, they're supplements. So in order to find the value of x, I'm going to add 30 plus x and 2x and set it equal to 180. Combine my like terms. Subtract the 30. 3x equals 150. Divide by 3, and x equals 50. Because same side interior or consecutive interior angles are always supplements. Now for the next one, They want us to show that these four ordered pairs will form a parallelogram. Now, when you're given coordinates, you're either going to show that both pairs of opposite sides are parallel by calculating the slopes of all four sides and find that opposite sides have the same slope, making them parallel. That would be using the definition. The other way, I could do the distance formula and find the length of each one of the four sides and then show that opposite sides are congruent. Or I could show that one pair of opposite sides are both congruent and parallel. Either way, I'm going to use the slopes. That's going to be the easiest way for me because I'm going to graph it and then I can either do the slope formula or I could just count the rise and the run. Now, on the quiz and in the notes, we also had a variation of this question where I gave you 3 of the ordered pairs and I asked you to find the missing 4th one. So be able to do that as well tomorrow, depending on your version. So you may have to prove that something is a parallelogram by showing the slopes are the same or by showing the sides are the same by using the distance formula, or find a missing coordinate by just using the slope. Also, if I maybe gave you a different variation, let's say just like you did in the homework, I may ask you to find the coordinates of the intersection of the diagonals. And that's where you had to do the midpoint. So be able to do any of these calculations given ordered pairs. I'm going to be giving you a graph that you can graph the ordered pairs to give yourself a visual. And that's what I'm going to do on the next slide. So I'm going to go ahead and graph the 4 ordered pairs. I'm going to graph A first. The ordered pair for A was -1, +3. The ordered pair for B was 7, -1. The ordered pair for C was 6, -4. And D is -2, 0. Now, in order to show that this figure is a parallelogram, I would either need to have shown that these sides are congruent and these sides are congruent. I can't count squares. I would have to do the distance formula. Or what I'm going to do is show that both pairs of opposite sides are parallel. And remember, parallel lines have the same slope. So I'm going to just count the rise and the run. So my slope of BC, if I count the rise and the run, it's rising 1, 2, 3, and it's running 1. So the slope here for BC is 3. If I do the same thing for AD, count the rise and the run, 1, 2, 3, and then it runs 1. So far, I do have one set of parallel sides. I need to confirm the other set. Now, if you don't want to count rise and run, you can also do the slope formula. The y2 minus y1 over x2 minus x1. So to find the slope of AB, again, I'm going to count my rise and run. It's going 1, 2, 3, 4 up. I need to make sure it gets to the height that it's parallel. So then now, or on the same level, so that's 4. And then I'm running to the left. So 1, 2, 3, 4, 5, 6, 7, 8, -8. So 4 over -8 reduces to -1/2. I can do the same thing for CD. I could go fall down 1, 2, 3, 4, -4. But then when I run to the positive side, 1, 2, 3, 4, 5, 6, 7, 8. So then CD is -4 over 8, which also reduces to 1/2. So because both pairs of opposite sides are parallel, this is a parallelogram. So again, if you would have rather done the distance formula and shown that both pairs of opposite sides were congruent, you could do that as well. We know nothing about the angle measures, so we wouldn't have been able to use any of those theorems. So again, be able to find coordinates, be able to find a missing coordinate if I give you 3 of them. And again, I would have just calculated the slope and then moved the slope from one of the ordered pairs to find the missing one. We did it in the notes. Or if I ask you instead to find the coordinates of the intersection of the diagonals, like you did in the homework. Remember, the diagonals are bisected. So this point of intersection is the midpoint of either one of the diagonals. It doesn't matter which one you calculate. So be able to do all that. So again, this is a quiz review that is posted. I am not going to give you any real life examples. All of the figures are going to be like the ones that we just did in the warm-up, as well as all the pictures in 1 through 18. So this is a good place to start. You can go back, review your notes, review your homework. All of that is another good way to review.